Welcome to 7.5, Solving Rational Equations. So a rational equation, unlike what you've been working with thus far in this unit, is an equation, which means it needs to contain an equal sign somewhere already before you even start doing any kind of manipulation. And it needs to include at least one rational expression. The steps in general to solving a rational equation are you need to factor your denominators just like you would previously. You have to identify all your non-permissible values. Again, nothing new about that. And so we're really introducing a new idea when we get to step 3. And so what we're seeing is that instead of finding the lowest common denominator and then making sure that we actually achieve that, what we're going to do is we're just going to multiply the entire equation by that lowest common denominator in order to cancel out the denominators. Now, why we do this is because we don't like variables in the denominator if we're trying to solve for them. So this allows us to eliminate the denominator, move our variables up into the main line of the equation, and then isolate from there and use our algebra skills that we've been developing for the last few years. So it's really step 3. That's our new piece of information for this lesson. So example 1 says, solve, be sure to state your non-permissible values. So step 1 is make sure that the denominators are factored. In this particular example for A, they are. B says state our non-permissible values. So non-permissible values are when our denominator would be equal to 0. So if 2x cannot equal 0, that's a non-permissible value, which means x cannot be 0. That actually holds true again for 10x. We can check if you want. 10x cannot be 0. So x cannot be 0 either when we divide by 10. Okay, so that is my non-permissible value. I only have one. My lowest common denominator, this is step 3, is going to be a combination of all of these things. So I'm going to need an x, and I also need 2 times 5 is 10, so luckily that kind of all works out. So I've got 2x, 5, and 10x. My lowest common denominator of all of those is going to be 10x. So I'm going to multiply this entire equation by 10x. So you can write it out like this. You can also, and how I usually do it personally, is I'll write it in times 10x. And I write it in for every term so that I never forget to multiply by a specific term. So every term gets multiplied by that lowest common denominator. That's step 3. Now what happens is x divided by x cancels out. 10 divided by 2 turns into 5. So now it's just 1 times 5. X, well, there's no x here to divide it out, so that stays. 10 divided by 5, though, is 2. So that's going to be multiplying there. Finally, this whole common denominator cancels out with the denominator on the right-hand side. So again, I'm not going to write an equal sign on my left-hand side for my next line because I already have an equal sign in because this is an equation. So what we're going to do is we've got 5 times 1 is 5, minus 2 times 2 is 4, equals 1. Oops, and I dropped that x. Don't forget that x. 5 minus 4x equals 1. Okay, so just be careful on that. So we want to isolate our variable from here. So we want to move that 5. And so x is going to be positive 1. So my solution is that x is positive 1, but x cannot be 0. And there we go. You're good to go. Now you do always want to check to make sure that this is a legitimate possibility, and that's our final step, step 5 up there. So we check. By substituting back in 1 over 2 times 1 minus 2 over 5 equals 1 over 10 times 1. So we've got a half minus 2/5 is a tenth. Now we can just deal with the common denominator. So this is 5/10 minus 4/10 is a 1/10. That is true. So we know that our solution is possible. So good news, we're done. So again, the key thing is that we factor our denominator and find our non-permissible values, just like you were doing with rational expressions. But then we find that lowest common denominator, and instead of making sure that we have a common denominator, we're going to use that common denominator to actually cancel them out. We're going to multiply by them. So we see that with part B. Again, my non-permissible values is going to be x cannot be 0. My lowest common denominator in this case is going to be a comparison of x versus x squared versus a 1. Well, the most x's I need is 2 x's, or x squared. And I don't have any coefficients with my variables, so 1 is perfectly fine. So my lowest common denominator is just x squared. So that's kind of nice. So I'm going to multiply by x squared, multiply by x squared, multiply by x squared. Again, going through, I'm left with 1x here, and I'm going to circle it so that I don't forget, like I almost did in the last question. Both x's are going to cancel out here, and since there's no denominator, that x squared is going to stick around. So we've got 5x plus 6 equals 6x squared. Now, the difference here between A and B is that A gave us a linear equation, which is always nice to move around because our variable doesn't have an exponent. B is a little bit trickier. It is a quadratic equation, so I'm going to isolate it all onto one side, set it equal to 0, and solve for x from here. So we've got 6x squared minus 5x minus 6. I'm going to see if I can factor that. And we'll try and see if we can figure that part out. Okay, so we've got, I'm going to use the crisscross method to try and factor this out. So I've got 3x and 2, and then I've got negative 3 and 2. Sorry, that gives me 4x and negative 9x, which gives me my middle term. So these are going to be my factors. And so x will equal negative 2/3 and positive 3/2, neither of which are 0. That will be my solution. And again, we can check our answer by plugging back into the equation. Example C is much the same, except we're getting into a little bit more complicated denominators here. A and B were nice in that they were just single x's or x squareds, but no polynomial piece to it. Just monomials. So here, my non-permissible values become a little bit trickier. Here I get x plus 2 cannot be 0, which means that x cannot be negative 2. But I also get x minus 2 cannot be 0, so x cannot be positive 2. So I have two non-permissible values here. My lowest common denominator also gets a little bit more complicated, because I need to account for both pieces. And so I need to include them both. That whole thing multiplied together is now my lowest common denominator. So when I go to multiply this, and I'm just going to zoom in so that I can write and still be visible, I'm going to multiply each term by x plus 2, x minus 2, and we'll see kind of why we include both pieces. Okay, so when I go to cancel out, on my left-hand side, the one monomial or binomial cancels out. On my right-hand side, the other binomial cancels out. So that is why we need to find that lowest common denominator, and we need to include both pieces. There we go. Okay, so from here, we've got negative 3 times x minus 2. Make sure I distribute that into both pieces. Same thing with this 3 on this side, goes into both pieces of the binomial I'm multiplying by. So I've got negative 3x plus 6 gives me 3x plus 6. If I go to manipulate this and move it around, I get positive 6x equals 0, and so x equals 0, but x cannot be positive or negative 2. Well, that's okay this time, because so my answer, even though I'm like, oh, x equals 0, that's usually not allowed, and from our previous 2 examples, that's exactly what we saw. This example, x is allowed to be 0. If I plug it back in as my denominator, 0 plus 2 is positive 2, 0 minus 2 is negative 2. So both of those denominators are permissible. So there's my solution for C. D, we finally start seeing that factoring piece finally come into play. So if we pause and look at what we've got here, I'm going to rewrite this immediately into factored form. So I've got 7x minus 15 over, instead of x squared minus 9, I see that's the difference of squares, so x plus 3, x minus 3. And x minus 2 over x minus 3 on the other side. From here, now I can talk non-permissible values and lowest common denominator. So non-permissible values, I've got x plus 3 cannot be 0, so x cannot be negative 3. Conversely, x minus 3 cannot be 0, so x cannot be positive 3. My lowest common denominator, because we have a shared binomial here, I actually don't need to include it twice. Once is sufficient. So my lowest common denominator is what we see on the left-hand side. X plus 3, x minus 3. You're like, oh, I don't know about that, Ms. Konrad. I want to include that x minus 3 twice. I will show you why we don't need to. X plus 3, x minus 3, x plus 3, x minus 3. Well, both binomials cancel out on the left-hand side, so that's really nice. But on the right-hand side, that x minus 3 is already present. I don't need to write it twice, because just once is sufficient in terms of canceling. Now when I go to multiply on the left-hand side, luckily there's nothing to multiply, so that stays the same. 7x minus 15. But on the right-hand side, I actually have 2 binomials. That x minus 2 is basically like it's in brackets, because it's all part of that original rational expression on the right-hand side. So I'm going to need to FOIL that out. So firsts, outsides, insides, lasts. Just like we did in grade 10. So we've got x squared plus 3x minus 2x is plus x, and then minus 6. From here, because it is a quadratic equation, to solve for x, we need to get everything on one side and set it equal to 0, which is kind of different than when we're solving linear equations, if you remember. So we've got minus 6x and plus 9. And so when we factor that, we get x minus 3 squared. And so x equals positive 3. But x cannot be plus or minus 3, which means we've got what we call an extraneous root. Okay, so because our answer disagrees or is one of our non-permissible values, we call it extraneous. So our solution is a non-permissible value. Now we can double check this by trying to plug it back in, but we can feel pretty confident in our non-permissible values. But just if you want to check, which is always a good idea, especially if we get an extraneous root, just go back and make sure all your work is perfect. Okay, so we go 7 times 3 minus 15 over 3 squared minus 9 equals 3 minus 2 over 3 minus 3. And I'm just using those brackets to signify where my x's used to be. Well, 7 times 3 is 7 times 3 is 21 plus or minus 15 is going to give us 6 over 0 equals 1 over 0. Because we are dealing with over 0, these are not allowed. And so we're again proving the extraneous root. Okay, so let me just double check that I have the right value in there. It looks like we're missing a piece of that equation. Here we go. Okay, 35. All right, so again, step 1, just factor those denominators. Right-hand side is nicely already as simple as we can go, but the left-hand side maybe can be dealt with a little bit. Factors of 35 include 7 and 5, which when we add together get us 12. So I'm thinking that's where we're going with that. So negative 10 over x minus 5, x minus 7 equals x over x minus 5. So when we go to do our non-permissible values, again, we've got 2. We've got x minus 5 cannot be 0. So x cannot be 5. We also have x minus 7 cannot be 0. So x cannot be positive 7. Now luckily, when we see this denominator on the right hand side, again, we've got an overlap. We have a matching binomial in both denominators. So that makes life easy. We already know x can't be 5 for that one, which also means our lowest common denominator is a little bit easier too, because we only have 2 binomials to consider, x minus 5 and x minus 7. So again, we're going to multiply everything by those 2 pieces. On the left-hand side, everything cancels. On the right-hand side, just x minus 5 does, leaving us with negative 10 equals, distribute through the bracket, so it's going to be x squared minus 7x. Dealing with quadratics, we get it is equal to 0, x squared minus 7x plus 10, and we factor from here. Which finally means that x equals 5 and 2, but since x cannot be 5 or 7, that means that only x equals 2 is actually a true solution. Okay, again, we can plug back in, but we're going to see that 0 showing up right here and also in our left-hand side denominator. Okay, last example, and it's kind of looks like a monster. Don't worry, you still follow the exact same steps. So step 1 is still factoring. First expression, as simple as it can be. Second expression is as simple as it can be. Third expression, that needs to be factored. So I'm going to rewrite this equation. And I'm going to make sure that on my right-hand side, I'm going to factor that denominator. Okay, so factors of 24 include 6 and 4. Always check to see if what we have on the other side or in our other rational expressions actually work as factors in our more complex polynomials. Okay, so x plus 6 and x plus 4 end up being the factors here. So lovely, they match up over here. That's going to make our life a lot easier when we look for a common denominator. So our non-permissible values, if you're getting good at this, you can already pick them out, are going to be that x can't be -4 or -6. Again, you can follow the process that we've been doing so far. My lowest common denominator, because my lowest common denominator actually includes both smaller ones, or the ones that are in smaller pieces, I get to just say x plus 6, x plus 4, and that's what I'm going to multiply by. Now again, if you are pretty good at picking out things that cancel, I can, instead of writing it out beside each and every term, what you can do is go, okay, well, it's going to end up being x plus 1 times x plus 4 for my first term, because x plus 6s are going to cancel. My second term is going to be x minus 2 times x plus 6, because the x plus 4s are going to cancel out. And finally, on the right-hand side, because my lowest common denominator matches my denominator, it's just going to be 11x plus 32. From here, I'm going to go ahead and I'm going to FOIL these, because it's two binomials. And I'm going to get x squared plus 5x plus 4 plus x squared plus 4x minus 12 equals 11x plus 32. Well, again, I'm dealing with quadratics, and I want to collect like terms and get everything on one side and set it equal to 0. In this case, it's going to be easier to have 0 on the right-hand side. I've got 2x squared. 5 plus 4 is 9. Minus 11, though, it's going to give me negative 2x. Then I've got 4 minus 12 is negative 8. Plus 32 is going to get me positive, or minus 32 is going to get me negative 40. From here I can factor out that 2, so that part's nice. X squared minus x minus 20 gives me 0. And to factor this further, 5 and 4 are factors of 20. So it's going to give me x minus 5, x plus 4. And I know that it's 5 that's negative, not 4, again, because that middle term is negative. So when I add these together, I'm going to end up with negative 1. And so finally, x would be positive 5 or negative 4. Again, we have a non-permissible value where x can't be negative 4 or negative 6. Therefore, my final answer is actually just going to be x equals negative 4. Or sorry, not x equals negative 4. That's not allowed. X equals 5 with my non-permissible values. And this is extraneous. It lies outside our allowable domain. So I know that was a lot to practice. You've got more time to practice now. Work through the workbook, work through the extra practice. Definitely get a handle on that piece where we're now multiplying by a lowest common denominator, and make sure we're really watching out that we don't skip any pieces, that we don't just say that this is, say, x squared minus 12. Don't miss out the fact that it's two binomials, so we have to use our distributive property. We have to FOIL.